Hey everybody, and welcome back to another CSEC math exam review video. Today we're going to be looking at a set of paper 2 questions coming from the May-June 2013 past paper series, and we're going to jump right into it by starting with question number 2. In this video we're going to be covering concepts from factorizing to systems of equations to Venn diagrams to similar triangles to linear equations and a lot more. So stay tuned for a lot of good useful tips and strategies in this video. So number 2, we're going to start off with number 2, which says factorize completely 2x cubed minus 8x. Alright, so step 1 is to find some numbers and variables that are common to both terms right here. So I'm going to say what's common to the numbers is 2. And what's common to the variables would be, well, x, right? Can we take any higher powers of x out? The answer is no, because the highest power of x in this term is just x to the 1. So that leaves us with x squared minus, what number can we put here so that when we multiply 2x by that number we get back minus 8x, so that's minus 4. And again, you can check this as you go along by multiplying it back through to make sure you get what you started out with. Alright, and so, if you check this back, 2x times 2x squared, that's going to give you 2x cubed. 2 times minus 4 is going to give you minus 8, and the x will also be included. So that is correct. Awesome. So moving on to the next question. It says factorize 3x squared minus 5x minus 2. So looking at this power right here, this looks like the standard form of a quadratic equation. And we're gonna recall that to factorize quadratic equations, we need to use either the quadratic formula or something called the AC method, or factoring by grouping. We're gonna look at the AC method right now, and that's basically saying, can you think of two numbers that when you multiply them together give you the product of A and C and add up to B? Wait, hold on. What is A, B, and C right here? Well, in the standard form of a quadratic, A comes from this number, B comes from this number, and C is the number that stands by itself. So you're looking for what are two numbers that when you multiply them, they give you the product of 3n minus 2. 3n minus 2 is just minus 6, right? So two numbers that multiply to give you minus 6 and add up to give you minus 5. Well, those two numbers, if you take a moment and think about it, those two numbers are going to be 6 and positive 1. 6 plus 1 gives you minus 5, and 6 times 1 gives you negative 6. Now what do you do with these numbers? We're going to factor this expression by grouping. What that means is, think of you as splitting this middle term into these two various numbers. So we're going to rewrite 3x squared minus 6x plus 1x, or I'm just going to write x, minus 2. Now factoring by grouping says, let's look at the first two terms and look at the second, or the last two terms, as a set of pairs. And we're going to factor them individually in the same way we did part 1. What are two numbers that are common to 3x squared and minus 6x? Well, that's going to be 3x. What's left inside? One more x minus, well, in this case, 2. All right, really nice. And what is common to, in this last pair, x and minus 2? On the surface, it seems like nothing, but when that's the case, that means that 1 is the highest common factor. If you factor a 1 from everything inside, you're left with the same exact thing. Now what you'll realize is that x minus 2 appears in both of these terms. So what we can do as our final step is to factor out x minus 2 from each of these two terms. That means if we pull out x minus 2 in its own bracket, what's left behind? Well, that's going to still be multiplied by 3x plus 1. And there you have it. X minus 2, 3x plus 1 is the fully factorized version of number 2. All right, so I'm going to just move this. I'm going to move this aside so we can refer back to this later if needed. But we're going to move on to the next question, which says B. B says, make C the subject of the formula F equals 9 over 5 C plus 32, which is actually the conversion for converting Celsius to Fahrenheit. So that's 9 over 5 C plus 32. We want C to be the subject of the formula. So I want you to think about this like an onion, right? Where you kind of want to peel back the layers from the outermost part, zoning in on the part that you care the most about. In this case, that's C. So the furthest thing out is this plus 32. To get rid of a plus 32, we're going to subtract 32 from both sides, right? So f minus 32 equals, you can also think of this as 9c over 5 if you want. Now, to get c by itself and isolate it by itself on this side, we need to peel back the last couple layers of divided by 5 and multiplied by 9. The way we're going to do that is by multiplying by the reciprocal of this fraction. Multiplying by 5 over 9 on both sides is going to cancel these two numbers, leaving c by itself, leaving 5/9 times f minus 32. And remember, this 5 over 9 has to multiply by the minus 32 as well. And that is c as the subject of the formula. All right, 2 marks in the bag. Given that f, moving on, f is 113, what is c? Okay, well, 5 over 9 multiplied by, f is now 113. We've substituted that. Minus 32 equals c. All right, and now because this is the calculator section, you can definitely use your calculator if you are so inclined to say 113 minus 32 is equal to 81. Multiply that by 5 and then divide that by 9 gives you 45. So 45 is C. All right, I'm going to minimize this again and we're going to move on to the next question, which says, the next question says, 500 tickets were sold for a concert. Of these, X tickets were sold at $6 each and the remainder at $10 each. So what I'm thinking is that this is actually a hidden systems of equations or simultaneous equations problem. The way that we do this, right? How many tickets were sold in total? Well, 500. So if 500 tickets were sold, we know that there are actually 2 types of tickets that comprise this 500. The first one is the $6 tickets and the second is a $10 ticket. So let's call the $10 tickets Y, the number of $10 tickets sold, and X, where X is the number of $6 tickets that were sold. So if you add X plus Y, if you add the number of 6 and the number of $10 tickets, it should be equal to 500 tickets in total. This is your first equation. All right, the next bit says X tickets were sold at $6 each and the remainder at $10 each. Write an expression in terms of X for the number of tickets sold at $10 each. So an expression in terms of X for the number of tickets sold at $10 each. We've already done that in the first equation. All we need to do is make Y the subject by saying 500 minus the number of $6 tickets sold leaves the number of $10 tickets sold. This expression is your answer for part A. Okay, the total amount of money collected for the sale of the 500 tickets. The total amount of money collected for the sale. All right, so we know that for each $6 ticket, we get $6. So if we say 6 multiplied by X, what does that mean? That means $6 for every such ticket sold. Plus, well, we're going to multiply 10 multiplied by how many $10 tickets were sold. Well, from our previous answer, we know that that is the expression 500 minus X. And right there, this expression, which we can simplify as 6X plus what's 10 times 500? 5,000. What's 10 times negative X? Minus 10X. Sorry, this should be 5,000 minus 10X. 6X minus 10X. That's going to be 5,000. That's going to be 5,000 minus 4X. And this right here is your expression for the value of all of the tickets sold. All right, so now part 2 is going to build on that and say the sum of $4,108 was collected for the sale of the 500 tickets right there. So calculate the number of tickets sold at $6 each, which, by the way, remember, that was just X. So it's saying all of this, 5,000 minus 4X, should be equal to $4,108. Find X. Okay, So we're gonna rearrange this to say 5,000 minus 4,108 gives you 4x. All right, and if you again want to be sure about it, you can use your calculator, because I know you guys really love to use your calculators. 5,000 subtracted by 4,108, even though this is math that you could do in your head, that's 892. 892 is 4x. Therefore, x should be 892 divided by 4. 892 divided by 4 is simply 223. 223 is equal to x. And there you have it. This is the number of $6 tickets sold.